I've been doing some work on black holes, and there's progress being made on that now, which I think is profound and exciting. So they are stars at the end of their life, bigger than the sun, more massive than the sun. But they run out of their fuel and they start to collapse as gravity squashes them. And if they're sufficiently massive, then there's nothing that can stop the collapse. And so they collapse, as far as we know, to a point, right, essentially an infinitely dense point. But they collapse to such an extent that there's a region around it from which light can't escape. And so nothing can escape. And that's a black hole. They're surrounded, this region where if you fall in, it's called the event horizon. And if you go across that horizon, then you are going to the center. There's one way of thinking about it, which is quite cool, which is that the time and space sort of flip is one way to think about it. So in the same way that we are going into the future now, so we're going to tomorrow. There's nothing we can do about it. We are going to tomorrow. In the same way, if you fall in across the event horizon of a black hole, you are going to the middle, the singularity it's called. So that's your future. Every line of your future points to the center of the black hole. We have now got photographs of them. So we have 2 photographs, which are radio telescope photographs. One of the one in the center of our galaxy, which is a little one. It's called Sagittarius A star. So it's about 6 million times the mass of the sun. And they took a photo of one in the galaxy M87, 55 million light years away. That thing is around 6 billion times the mass of the sun. So if you took our sun, which you can fit 1 million Earths inside, and collapsed it down to make a black hole, it would form a black hole when it shrunk. So you squash it down till it's about 2 miles, and then that would form a black hole. 6 billion times the mass of the sun means you multiply that by 6 billion. So these things, the so-called Schwarzschild radius is larger than our solar system. So what you're seeing there is the emission from the material that's swirling around it. It's called the accretion disk. So you have material that's orbiting very fast, emitting a lot of radiation, and that's what you see. It's a flat disk, by the way. Think Saturn's rings. So this material is very flat. But what you're seeing in that photograph is the light rays being bent around the black hole from that flat disk. So that was a prediction from Einstein's theory, basically. He published it in 1915. And you can predict that that's what one should look like. And then just about, what was that, 4 years ago now, maybe 5 years ago, for the first time in history, we get an image of one, and it looks like the prediction.